The purpose of this video is to go over these solutions for this final exam review for this MDM4U or data management course. And the first question on the first page here is a matching question. Notice that there's actually 25 answers here, but there are only 16 questions. So there are, 9 questions that answers up here that aren't going to be used. Nothing is used twice. So for the first one, it says this type of probability occurs when the probability of a particular event is determined by dividing the number of times that the event actually occurs in an experiment by the number of trials. And so that's called an empirical probability because it was probability that was determined from an actual experiment that was conducted. Number 2, this is probably tossing a pair of coins and getting 2 heads. So if you were to draw a tree diagram and list the sample space, or just list the sample space for tossing 2 coins, you could get 2 heads, or a head then a tail, or a tail and then a head, or 2 heads, or two tails, sorry. So probably getting 2 heads, there's only one way that occurs out of the 4, so there's probably 1 chance in 4, which is answer K here. For question number 3, this type of probability distribution can only take on whole number values, and that's a discrete probability model or distribution. Whole number values means it's something that's countable, so not measurable. Measurable is continuous, and there's a continuous one here in a little bit. For number 4, this distribution has a certain probability of success that remains constant through all the trials. And the answer is G, that's a binomial. For a binomial probability model, the probability of a success remains constant all the way through because you're sampling with replacement. The hypergeometric is the one that you're sampling without replacement, so the probability of success changes from trial to trial. Number 5, this type of calculation is used to find the number of possible ways you can select a group. Now notice it says group, so order is not important, of 5 people from 12. So if it's just groups, it's a combination. And so for J here, we would use the combination answer. For number 6, 12 permute 4. Now the formula to calculate a permutation of n objects taken r at a time looks like this. So, and there's a couple of ways to write this, NPR. So it's n factorial over n minus r factorial. So the calculation would be 12 factorial over 12 minus 4 factorial, which of course is 8 in the denominator. And that is answer C up here. For question number 7 next, the hypergeometric distribution samples without replacement, which is answer M here. All the possible heights that a teenager could be is an example of this type of sample space. And so heights of a person, a teenager or otherwise, is something that's measurable, not countable. And so that's why the answer is E, which is continuous. For example, you could be 160 centimeters tall, or 161, or 162 centimeters tall, or any number in between. So it's not like you can just be 161 and then you grow instantaneously, become 162. You could be something in between. So that's why it's continuous. This expression is equivalent to both of these, and these are both different ways, different symbols or ways to write 20 choose 5. These are combinations. And the combination formula looks a lot like the permutation one, with one difference. So it does start with n factorial in the numerator, and it does have an n minus r factorial in the denominator. But it also has, in addition to that, an r factorial. And that's what makes this different than the permutation one, is that extra r factorial. So if I were to write out 20 choose 5, that would be 20 factorial over, and we would go 20 minus 5, which is 15 factorial, and also the 5 factorial. Now it says the answer is D here. I'm just going to scroll up a little bit. D is 20 choose 15. So just want to demonstrate why that is the same as 20 choose 15. So 20 choose 15 according to this would be 20 factorial over, and 20 minus 15 is 5 factorial, and then also the 15 factorial in the end. So notice that they are the same. They both have 20 factorials in the numerator, and it doesn't matter whether you say 5 factorial times 15 factorial or the other way around. It doesn't matter if 15 factorial is first or second, multiplying those is the same thing. So that's why 20 choose 15 is the same as 20 choose 5. Notice they both have an n value of 20 at the beginning, and the 5 and the 15 add to that 20. As long as those two R numbers add to the 20, those combinations would always be the same. And of course, that is the B answer the D answer for number 9. For number 10, an expression equivalent to 8 times 7 factorial. Now let me get rid of a little bit of what I wrote here so I have some room to write. So what this is equal to would be 8 times, now 7 factorial is the product of all the numbers from 7 down to 1. So now what we actually have is the product of all the numbers from 1 up to 8, so that's equal to 8 factorial, which is answer B. If we scroll up, 8 factorial. For number 11, 17 permute 2 using the permutation formula again would be 17 factorial over 17 minus 2 is 15, so there'd be a 15 factorial in the denominator. And that should be answer S, which is right there. Number 12, a type of diagram used to show how groups of data overlap, and I put a little hint there, circles and ovals. It's called a Venn diagram, which is answer A. So Venn diagram, that's the A answer. Number 13, this type of probability is determined by listing the sample space and then dividing the number of successes by the number of items in the sample space. And so that is a theoretical probability model. So answer T is theoretical probability. So that's theoretically what should happen, okay, without performing an experiment. Experimental probability won't necessarily be the same. It'd be quite close if you perform a sufficiently large number of trials, though. Number 14, the probability of an impossible event would be 0. If it's impossible, it has a 0% chance of happening, and that's answer V here. Number 15, two events that cannot happen at the same time are said to be, and the answer is U here, and they are called mutually exclusive. It's like if you were dealing from a deck of cards, it would be impossible to get, for example, a face card, which is a jack, queen, or king, and let's say a card below 5 at the same time. So those would be an example of mutually exclusive events because they have no elements in common whatsoever. Number 16, if the probability of A is 0.05, then the probability of not A, and not means the complement. So we would go 1 minus the probability of A happening, which would be 1 minus the 0.05, which would be 0.95. And so that should be answer H. We'll scroll up here, and H is the 0.95. There we go.